Hello all, welcome to the 7th episode of Introduction to Functions. In this session, we are going to talk about something called as a domain of a function. Now, domain of a function is quite an important topic, but quite often it's a little confusing to the students, but it's not that complex at all. So let's get into the domain. Let's say we have a function y is equal to 2x plus 5. And if we were to plot this function on an xy axis, as we saw earlier, what we do is just create a simple table, get some points of x and y and join them. So in this case, if we put x equal to 0, we get y is equal to 5. We put x equal to 1, we get y equal to 7. We put x equal to 2, we get y equal to 9. We put x equal to minus 1, we get y equal to 3. So we get some points, right, the coordinates of the function. All we do is we plot these points and then we join them. And this is how we plot this function, right? So in this case, as we see, there is no restriction in the sense that I can pretty much give any value to x and get a corresponding valid unique value of y, right? I can give x equal to 1 million and I will get a corresponding value of y, right? Now let's take another example. So this is our another function. Y is equal to 10 divided by 5 minus x, right? We can do the same thing here. We can give different values of x and find the corresponding values of y, get those coordinates of x comma y and plot them on the graph, right? But we do notice here that when x is equal to 5, the value of y becomes undefined, right? So let's see. When we put x equal to 5, the value of y becomes 10 divided by 0, which is undefined, correct? So essentially, x can never take a value of 5, right? It can take any other value, but not 5. Hence, the domain of this function will be all the values from minus infinity to infinity except 5, right? Let's take yet another example. Let's say we have another function, something like this. Y is equal to square root of 2 minus x, right? Here, as we see, the moment x takes any value greater than 2, this entity inside the square root becomes negative. Let's say x is 2.1, right? This will give 2 minus 2.1, which is equal to square root of negative of 0.1. And we know that the square root of a negative number is not defined in the real world. Hence, the point I'm trying to make is that for any value of x greater than 2, y will not have a real valid value. Hence, the domain of this function will be all the values of x from minus infinity through till 2. X can also take a value of 2 because 2 minus 2 is 0 and the square root of 0 is 0. But x cannot take any value greater than 2, right? Now there are different ways of representing the domain and we're going to see that in a moment. Now that we understand what the domain of a function is, let's understand how do we represent it mathematically. Taking our previous example, we just saw that the domain of this function is nothing but all the values from minus infinity through till 2, right? Now, how do we convert or represent this English statement mathematically? There are two ways of doing that. One is called as the inequality notation and the other is called as the interval notation. Let's look at each of these one by one. So in the inequality notation, what we do is we write x here and x can take any value greater than minus infinity and then x can go through till 2, so less than 2. So basically what we are saying in this notation is x can take any value which is greater than minus infinity but less than or equal to 2. In this case, since x can also take the value of 2, it has to be less than or equal to. So this is the way in which we represent the domain of this function in the inequality notation. Let's now look at the interval notation. So in the inequality notation, we use the inequality signs to represent the domain. In the interval notation, we used two different types of symbols. One is the square brackets and the other is the parenthesis. Square brackets are used to denote those values which are a part of your domain and parentheses are used for the values which are not a part of the domain. Let's see what I mean by saying that. So in this case, the domain of the function is all the values greater than minus infinity, right? So we put a parenthesis because minus infinity is not included as a part of the domain. And then we put a comma sign here and then we see the other limit, which is 2. But since 2 is also a part of the domain, we use the other symbol, the square bracket. So this is how we represent the domain of this function in the interval notation. What it means again is that the domain of this function is all the values of x from minus infinity, obviously not including minus infinity, through till 2 and including 2 as well. Hopefully you guys got a good understanding in terms of what the domain of a function is, how do we find it, and how do we represent it mathematically, either in an inequality notation or in the interval notation. Hope you guys liked the video. If you did, please do like and subscribe.